Alright, so today we're going to be talking about parts of an exponential function, and I just kind of want to review the general equations for an exponential function. And if we're looking specifically at growth, that means where b is going to be greater than 1. A is what we call our y-intercept, or something called initial value. So a being our y-intercept, it's the initial value we start at. If b is greater than 1, then that is showing growth in our graph. Our graph will be an exponential growth, and then b is what you call the growth factor. All right, factor is different than rate. All right, b is just the growth factor. If you want to find the what we call growth rate, or labeled as r, what we have to do is b equals 1 plus r. So to be able to find r, we're going to subtract 1 from both sides, and r is actually going to equal b minus 1. So if we want to find our actual growth rate, we're going to have to do b minus 1. Now, let's look at if it's exponential decay. It's not much different, except there is a little bit typo. So this is looking at, if it's not b is greater than 1, right? Because that's exponential growth. It's actually where b is greater than 0, but less than 1, right? That's exponential decay. So a is still our initial value, right? It's still our y-intercept. That has not changed. But when our b is between 0 and 1, that is what we call decay. And we know this. This is what we've been reviewing. So then when we're looking at b, right, this is going to be decay factor. Just like the other one was growth factor, this is decay factor. Now r, to get the decay rate, right, if we want to find r, b again, okay, instead of 1 plus r, it's going to be 1 minus r. So to find your growth factor, or I'm sorry, your decay factor, it's going to be b equals 1 minus r. So what r actually equals is going to be 1 minus b. And so to find your decay rate, all right, that's going to be r equals 1 minus b. To find your growth rate, that's going to be b minus 1. So actually, let's just go ahead and practice. All right, let's practice some scenarios where we have to find the initial value, the decay factor, and decay rate. So we're going to identify the initial factor, identify if it's growth or decay. Then we are going to find the growth and decay rate. So if I'm looking at number 1, I need to decide if it is going to be growing or decaying. Well, what is b? b is 1.8. So b is larger than 1. That means it is going to be growth. My initial value is a, and so a is what comes first. So a equals 3, so my initial value is 3. My growth, it's going to be a growth factor, right? So my growth factor is just b, and b equals, right, 1.8. So that is my growth factor. Now, my growth rate is actually going to be, right, it equals b minus 1 because it's growth. Okay, so because it equals b minus 1, my rate equals 1.8 minus 1, which equals 0.8. That is my growth rate. So what you want to have, r equals 0.8. All right, so let's try this next one. So for number 2, again, is it growth or is it decay? Well, what is 1.04? Is b bigger than 1, or is b between 0 and 1? And well, anything, it's 1.04, so it's obviously going to be b is bigger than 1, so it is growth. Now my initial value is what comes in front, so it's going to be 2.1. My growth factor, because it's not decay, right? We're not looking at decay, we're looking at factor, is whatever b is, and b equals 1.04. All right, now again, my growth rate equals b minus 1. All right, so I'm going to have R equals 1.04 minus 1, which equals 0.4, and that's my rate. Okay, so let's go ahead and turn the page, and let's do a couple more examples. Now, looking at this example, number 3, am I growth or decay? Well, looking at number 3, being that I have 0.8, B is actually between 1 and 0, right? So it's going to be decay. All right, well, if it's decay, that's fine. So my initial value, again, is what comes first, which will be 9. My growth or decay factor is the B value, and B value equals 0.8. Now, this being a new one, right, we haven't had to work with decay. My rate is actually 1 minus B. All right, so when I plug that in, I have 1 minus 0.8, which leaves me to be 0.2 as my decay rate. All right, factor and decay. Factor and decay. Decay factor and decay rate are two different things. So we always have to use for decay rate, we always have to use the R equals 1 minus B. Let's try number 4. All right, so looking at number 4, it looks oddly similar to number 3. So what I want you to do is change 9 to 12.5, and I want you to change 4 to, not 4, 0.8. I want you to change 0.8 to 1 minus 0.6 to the x power. All right, so now looking at this, I can't instantly tell if this is growth or decay. So first I want to simplify. So I still will have my 12.5 on the outside, but what is 1 minus 0.6? And that actually is going to be 0.4 to the x power. So now that I have my new equation, right, I need to decide if it's growth or decay. Well, 0.4 is in between 1 and 0, so it's going to be decay. Now, what is my initial value? Well, it's whatever is on the outside, which is 12.5. Well, what is my decay factor? That's going to be just the value of B, so it's going to be 0.4. And then my decay rate, and again, rate equals 1 minus B this time with decay. So I'll have 1 minus 0.4, which is actually coincidentally 0.6 is my decay rate. All right, let's try number 5. Number 5, y equals 2 times 0.94 to the x power. All right, well, is it growth or decay? 0.94 is actually between 0 and 1, so it is decay. My initial value is whatever number comes first, which is 2. And then the decay factor is going to be just what B equals, which is 0.94. And then because it's decay, my rate equals 1 minus B. So then I'm going to have 1 minus 0.94, which actually equals B. Not B, it is definitely R, which equals 0.06. And that is my rate. Number 6 is a little bit tricky. What's different about number 6? Well, number 6 doesn't have the obvious number in the front. So if it doesn't have an obvious number in the front, I still have parentheses there. But what number really is in the front if I don't see anything, right? It's going to be a secret 1. So if I'm looking at growth or decay, I'm looking at B, right? And B is 0.3, so it is between 1 and 0, so it's going to be decay. But my initial value, being that I didn't see anything, is actually going to be 1, and then my decay factor is going to be 0.3. Well, when I want to find the decay rate, since it is decay, I have to use the formula R equals 1 minus B. And so R equals 1 minus 0.3, which equals 0.7 as my decay rate. All right, let's look at number 7 real quick. Number 7. Number 7, is it growth or decay? Well, what's B? B is 2. So 2 is greater than 1, so it's going to be growth. Our initial value, again, is what comes first, which is 3. So you're going to have 3 as your initial value. Growth factor, well, that's just B, and B equals 2. And so lastly, because it's growth, let's remind ourselves, because it's growth, it's going to be R equals B minus 1. All right, so R equals 2 minus 1, which equals 1. All right, let's turn the page and look at some more problems. All right, looking at the Johnson Company, right, they calculate that the value of its stock each year by using the function y equals 120 times 0.98 to the x power. Well, let's look at this. If I'm looking at y equals 120 times 0.98, is it growth or decay? Well, 0.98, that's decay, right? 0.98 is between 1 and 0, just barely, but it is decay. All right, my initial value is what comes first. So 120. My decay factor is just B, and B equals 0.98. My decay rate, again, is going to be 1 minus B, and 1 minus 0.98 is 0.02. And so that is my decay rate. Let's look at, lastly, number 9. All right, so Selena's starting salary for her new marketing management job is $32,000. Not bad. She calculated her projected salary for the next 5 years by using the function y equals 32,000 times 1.12 to the x power. All right, well, let's look at this. Is Selena growing in her job, or is she decaying? Well, 1.12. That is indeed greater than 1. It is not between 0 and 1, so it is going to be growth. Her initial value, well, it's what she made, right? What her first year in the marketing job, it's 32,000. And we can also tell because it's the starting number. Her growth factor is just what B equals, which is 1.12. And then her growth rate, all right? So her rate is going to be B minus 1. Well, B minus 1 is 1.12 minus 1, which equals 0.12. So, your homework for tonight is going to be page number 20. All right, it's going to be page number 20, as well as page number 21, and lastly, page number 22. But really, we just want you to look at the growth. Is it growth or decay? What the factor is, and what the rate is, and what the initial value is.